Hello students, in this class we will learn the shape of the conic section is about parabola. Let us see the definition first. A parabola is the set of all points in a plane that are equidistant from a fixed point and fixed line in the plane. To understand this definition, see the diagram here. This is the set of all points in a plane which are equidistant from the fixed point, this name as F, and fixed line. So if we take any point on this P1, P2, P3 and so on, these points are equidistant from the fixed point to the fixed line. Okay. Here the fixed line can be denoted as L. Here the fixed line is called directrix. The fixed line L is called directrix, and the fixed point F is called focus. Now check the definition of axis. What is axis? A line through the focus and perpendicular to the directrix. The axis of parabola. Check the diagram here. Suppose this is the fixed line and this is the set of all points in a plane. This curve indicates the set of all points in a plane is a parabola. This is the fixed line, that is the focus. This is L and this is F. Now a line passing through the focus and perpendicular to the directrix means this is the line passing through the focus and perpendicular to the directrix is called axis. So this is axis of the parabola. This is directrix and this is focus. Now See the definition of vertex. What is vertex? The point of intersection of the parabola with the axis. This is called vertex. So vertex of the parabola. In this diagram, this is the vertex of the parabola. Why? Because this is the point of intersection of the parabola and the axis. Now we will learn how to form equation of parabola. So the equation of parabola is the simplest if the vertex is at the origin. Suppose to derive the equation of the parabola, let us draw a rough graph here. Suppose this is the set of all points in a plane, means this is the parabola, and which is a fixed point f, and this is the fixed line, call it as L. A line perpendicular to the directrix, fixed line, and passing through the F means focus, is called axis. So this is axis and this is vertex. Vertex is at origin, we assume. So V 0, 0 here, and this is L. Now we assume any point, set of all points on the plane, suppose P, which is equidistance from the fixed point to the fixed line. So the distance from this point P to F and to the line must be equal by the definition of parabola. Okay, this point of contact, we assume this as B. Suppose the distance between B to P and P to F must be equal. That is the definition of parabola. Assume this as x-axis, and from origin to this point we assume the length is A unit. The length is from this to this, the length is A unit. That's why up to this, that's why the coordinates of the point F is A, 0, because it is completely lies on x-axis. The x value is A and y value is, there is no y value because it is completely lies on x-axis. Okay, so this is the origin. From origin to F there is A units, which is right side of origin. We indicate it as positive. If the left side of origin, it indicates as negative. The distance from origin to this line is minus A units because it is left side of origin. Okay, to the left side of origin we assume all values as negative. To the right side of origin we assume all values as positive. So it's minus A because the distance from this point to this line and to this fixed point are same. That's why the directrix equation is x is equals to minus A. Suppose the coordinates of this point B is, here x value is minus A and there is no fixed y value, we put our y value as y only. And we assume P be the point with the coordinates x and y. The perpendicular line which is passing through the origin means vertical line which is passing through the origin is called y-axis. This is y. Now by the definition of parabola, the distance from B to P and the distance from P to F are equal. Then by definition of parabola, PF is equals to PP. This is x1, y1. Assume this as x2, y2. Now distance between these 2 points as x1 minus x2 whole square plus y1 minus means y minus y2 means 0 whole square is equals to, assume P as x1 y1 and this is x2 y2. So by this x1 minus minus of minus x2 means a, y2 means y whole square. I wrote x minus a whole square plus y square is equals to x plus a whole square plus 0 square. So taking squaring on both sides, here the required value is x minus a whole square plus y square is equals to x plus a whole square. Using a minus b whole square formula here, a square plus b square means a square minus 2ab means 2ax plus y square is equals to, here we use a plus b whole square formula, a square plus b square plus 2ax. Here plus x square, here x square, both are cancelled. A square also cancel. Now the remaining values are here. So y square is equal to 2ax plus 2ax, 4ax. This is the parabola equation if a greater than 0. A greater than 0 means it opens right side. We conclude that, note, a greater than 0, since a greater than 0, here x can assume any positive value or 0 but not negative, and the curve extends, and this curve extends in the first quadrant as well as fourth quadrant indefinitely for into the first as well as fourth quadrant. The axis of parabola is x-axis. This is the derivation of equation of parabola if a is positive and the axis of parabola is x-axis. Then we have the equation of parabola is y square is equal to 4ax. So similarly we can derive y square is equal to minus 4ax, x square is equals to 4ay, x square is equals to minus 4ay. So these are all known as standard equations of parabola. These are all known as standard equations of parabola. Observe these four standard equations of parabola here. We have some observations. Parabola is symmetric with respect to the axis of the parabola. Second point. If the equation has y square term, if the equation, this equation has y square term, then the axis of parabola is x-axis and it is symmetric about x-axis. Means symmetric line means the x-axis divides the parabolic curve in two equal parts. That's why the axis of symmetry is x-axis. Then the axis of symmetry is along the x-axis. If the equation has x square term, so if the equation has y square term, then the axis of symmetry is along x-axis. Reversely, if the equation has x square term, like this, x square is equal to 4ay or x square is equal to minus 4ay, then the axis of symmetry is along the y-axis. If the axis of symmetry is along x-axis, A, the coefficient of x is positive, then the shape of the parabola is opens right. Means it is in the shape of like this, it opens right. If the coefficient of x-axis is positive. B, the coefficient of x is negative, then the parabola shape opens left, like this. Suppose this is axis of symmetry, x-axis, and this is y, This is a directrix. It opens left means, so the parabolic shape is like this. If the axis of symmetry is along y-axis, in that first point, coefficient of y is positive, then shape of the parabola is opens upward y-axis, and the coefficient of y is positive. This is x-axis. The coefficient of y is positive, it opens upward. This is directrix. B, coefficient of y is negative, then shape of the parabola is open downwards. The shape of the parabola is like this. This is f and this is also f. So these are all observations from the standard forms of parabolic equations.